This is the electrical revision questions, number 3. Again, we've got 3 parallel resistors, so I'll draw it, and I now know that the total current is 2.5 amps, and I also know that the supply voltage is 270 volts, and that the resistors, whatever they are, have the same value, and that's the key in this question, because if I work out the total resistance, which is 1 over RT equals 1 over R plus 1 over R plus 1 over R, that actually turns out to be 3 over R. So there's a straightforward relationship between the total resistance and the value of each resistor. And again, I'm after finding the value of these 3 resistors and then the minimum power rating. So let's have a go. See if you can do it using the straightforward formula for 3 resistors in parallel, and remembering what I said about the fact that the resistors are equal. I know the current, so the first thing to do is find the total resistance using Ohm's law, and then once I know the total resistance, I can then use that to find the value of each resistor, and then knowing that, I can determine the minimum power rating. Okay, so we'll go at it. So, what is RT? Using Ohm's law, the total resistance is V over I, so that's going to equal the voltage, which is 275 volts, divided by the current, which is 2.5 amps. So, using a calculator, I can work out what the total resistance is, and it turns out to be 110 ohms. So now, using the formula for resistors in parallel, RT is 1 over RT is 1 over R1 plus 1 over R2, but as they're all the same, that's going to be 3 over R, because of what I was saying earlier. So inverting this, R over 3 equals RT, and so the resistor is actually 3 times whatever the total resistance is. So in this particular case, that equals 3 times 110, which is 330 ohms. Now, if we look at the circuit, that makes sense. If each of these resistances is 330 ohms, for argument's sake, 330 ohms, and the total resistance is 110, if you think about the current flowing through this, if I had just one resistor, so one of these resistors, then I'd have a certain amount of current flowing for this particular voltage. If I had another resistor in parallel, what's going to happen to the total current? I've got 2 resistors. Each of these resistors will take that current as I've calculated, so the total current must double. There's another route. The current can go this way, but also this way. Now I add a 3rd resistor, there's another route the current can flow. So there's actually 3 lots of this current. And so the total current will be 3 lots of that. So in other words, every time I add a resistor, I'm increasing the current by the same amount. So that is another way of saying, each time I add a resistor, I'm reducing the resistance. If I add one resistor, another resistor which is the same in parallel, I expect to be half the total resistance. If I add another resistor in parallel, I expect to be a 3rd. And if I add a 4th resistor, effectively a 1/4, and so on. So if the particular resistor is 110 ohms, 330 ohms, I have 3 of them, that's a 3rd, which is 110. If I had another one, that would be a 1/4 of 330, whatever that is. So that's a quick way of finding resistances if they're all the same value, of course. So that's part A. Now part B, again we can use the power equations to find the power. So see if you can do this part of the question, end up with 230 volts. The power rating, the minimum power rating. Well, again, I've got 3 formula I can use for power, but probably V squared over R is the easiest to use because I know the voltage is 275 volts, and the resistance of each resistor is 330 ohms, because I'm after the power for each resistor, and that will actually give me the value to about 230 watts. That's very significant figures.